This next series of videos contain a collection of miscellaneous but nonetheless very useful tools and facilities which will assist you in your production work. And the first item to discuss is the Auxiliary Coordinate System, or ACS for short. If you remember, back in the advanced dimensioning videos, you rotated the view to help with dimensioning the three blocks that were offset from each other. That was a simple example of a temporary view rotation. But in your professional work, you may find it more advantageous to store sets of different auxiliary coordinates to assist in completing designs. ACSs are also very important when you work in 3D designs. ACSs allow you to quickly change the compass orientation in both 2D and 3D space, and equally important, to save the ACSs for future use. The ACS system provides an efficient method of storing different coordinate orientations together with different origin locations. An ACS is a coordinate system, which is the orientation of the X, Y, and Z axes, that differs from the design plane or world view coordinate systems. The difference between an ACS and a rotated view is that the ACS does not require the view to be rotated for the coordinate orientation to change. And you'll find that AccuDraw also plays a very large part in working with an ACS. All very confusing? Don't blame you. Let's try this simple example to see the system at work. Now on the screen, you can see several different objects. First is this pictorial view of a Y-shaped block. The block has two rectangular holes in each of the two arms. On the left here is a front view of this object, and I want you to draw that yourself. There are no dimensions, but as long as you have the proportions approximately correct, that's just fine. The end result of the exercise will be as shown below, where we see the two auxiliary views of the left and right arms of this object, together with the hidden information for the holes. The point of the exercise then is that the auxiliary views are difficult to draw since they are angled projections of the object's two arms. However, if you create an ACS for each arm, the two auxiliary views become very easy to build. So if you would draw that front view first, then we can begin. And I'm going to zoom in a little bit here so I can look a little closely at the front view. When you've drawn the front view for me, go to the ACS icon, which is in the primary bar. And again, if you can't see it, right-click on that bar and select the auxiliary coordinates icon. Click on that. This opens the auxiliary coordinates dialog box. Take a quick look at what's available here. The four tools here are simply standard file type functions, and the remaining 8 tools relate to ACSs. We can define an ACS by a face. We'll do that a little later. We can define one by points. We can define one by a view and one by a reference file. And then these are manipulation tools for the current ACS. Below you'll see an existing ACS, and you'll have one too. Your numbers are likely to be quite different. And these are showing the details of the current ACS, which is unnamed at the moment. Now we're going to add ACSs to this dialog box. And one last thing, we need to see the actual ACS icon on the screen. So go to View Attributes and turn on the ACS triad if yours is not already on. The ACS triad displays in the bottom left corner of the screen. So the first thing I'm going to do is to create an ACS for the left arm of the object, and we'll call that the arm A, and we'll call the right one the arm B. And the first tool I'm going to use is this one, which is Define ACS by Points. If you click on that, take a look at the Tool Settings window, and you'll see that you have 3 possibilities: rectangular, cylindrical, or spherical. Well, the cylindrical and spherical really relate to 3D work. So rectangular is the choice for 2D. And notice that I'm dragging with me the ACS icon. Now this is defined by points, so I need 2 points to define the orientation. I'm working on the left arm, so I will select this corner first, and then this corner here. And that now defines the rotation of the coordinate system. If you do the same, you'll notice that in the dialog box, the X and Y origins have changed values as you have defined this new ACS. So the next thing to do is to save this ACS, and we'll do that over here with the Create a New ACS icon. So we click on that. It says unnamed, and I'm going to call this A, since we're dealing with the A arm. Just A will do. That's all I need. And now we have a saved ACS. Notice that both the saved and the unnamed above have the same coordinate information. Keep in mind, of course, that your numbers will be different from mine. Well, having created the ACS, what do we do with it? Well, let's see. I'm going to move over here a little bit. I'm going to start the line tool in preparation to start developing the left auxiliary view. And if I now click on this corner, snap to that corner, and drag, you'll notice that the compass is now aligned with the new ACS. And now it becomes a simple job to create that auxiliary view. I'm going to right-click to stop that, snap to this point, F11 and O key, put the compass there, move outwards a little bit, start the first edge of the auxiliary view, and I think I should change that to a weight of 1. Hit enter to lock myself to the axis, find this corner, go in this direction. Again, no dimensions, so any dimension will do. Drag this way, enter, find my corner, come back to my corner, and there's the start of the auxiliary view. So obviously a very simple thing to do with the rotated compass. And I'm going to leave that there for the moment. So let's go next to the right arm and develop that ACS. And this time I'm going to use the define ACS by face. So we'll start that tool. Again, we have the same options, rectangular. We don't need to flip Z, which is a 3D function. And this time I simply data point on a corner, and MicroStation finds an alignment with that edge, or with that face in actual fact, and locates the ACS. Now I can change that location if I wish, or I can change the orientation. Notice the different colored circles. If I click on this colored circle, click and hold, I can actually manually rotate the compass. If I click on this red circle, it will automatically rotate at 90 degrees. I can do that either in the x-axis or the y-axis. So I'm going to leave that ACS right there, and now I need to save it. So I'm going to go to the unnamed ACS, don't want to redefine the A, create a new ACS, I'm going to call this one B, and we're done. I can left-click in the screen now to leave that orientation in place. So now I have two saved ACSs, A and B, both of which can be recalled at any time. I can now proceed again to develop the auxiliary view with those coordinates. And I'll leave that to you, as well as to add the two rectangular holes and develop the hidden lines as well. Now, switching between the ACSs is very simple. Just double-click the saved ACSs. There's A, and back to B. Double-click, back to B. So very easy and very quick to do that. Note that you can have different ACSs in each open view, so you're not limited to one set of ACSs for the entire design file. And before I finish this particular video, there are a couple of things I could mention. First of all, you can create an ACS without it being saved, which is what you do essentially whenever you locate and orient a new ACS. However, this is temporary and will remain active only until another ACS is selected or created. In addition, of course, you can import an ACS from a different model, as you can copy ACSs to different models directly as well. Now in the next video, we'll take a closer look at some more of the tools.